right, here we're taking a look at a sample of whole blood. This is a diagram of a test tube of blood where the blood has already been spun down. It's been sent into a centrifuge, and so the heavier things, the heavier elements have settled to the bottom of the tube, and the lighter elements, which is actually the liquid part of blood, is kind of floating at the top. So it represents whole blood, and when we separate it out this way, the fluid part that kind of floats to the top is referred to as plasma. And that plasma constitutes about 55% of the whole blood volume. The heavier part at the bottom that settled to the bottom, here in red, that represents the red blood cells, or in Latin we refer to them as erythrocytes. And I'll just indicate RBCs, right? RBCs for red blood cells, or erythrocytes. That constitutes about 45% of our whole blood volume. So when you do the math, right, 45 plus 55, hey, there's our 100%. Except for this little itty bitty bit here, you see a little layer of white on top of the red blood cells. That little layer of white is sometimes referred to as a buffy coat. And that represents the white blood cells, which we call leukocytes, and also the platelets, which in Latin we refer to as thrombocytes. And that constitutes less than 1% of the whole blood volume. All right, so I'll indicate that with a less than sign, less than 1% of the whole blood volume. And so you see our math does add up. So blood is mostly fluid, that would be the plasma, and red blood cells, and then in terms of volume, very little white blood cells and platelets. For now, I want to turn our attention to the plasma, the fluid portion of blood. And if we break down the composition of plasma, I'll use a slightly different color for that. When we break down the composition of plasma, it turns out that plasma is mostly water. Plasma is 92% water. Maybe you've heard someplace that the body is made up of mostly water, or at least the most abundant molecule in the body is water, and that's true. And it certainly plays out here in blood. All right, plasma is mostly water. That leaves about 8% for some other things. Most of those other things, in fact, 7% of those other things are actually proteins that are dissolved in that plasma. And so we refer to them as plasma proteins. And these plasma proteins serve various functions, in fact, a wide variety of functions. I'll give you an indication of some of them. For example, one of those plasma proteins is referred to as albumin. The job of albumin is to help hold the water in blood. We don't want the water to just leak out of the capillaries randomly, though some of it does leave the capillaries, but if we didn't have albumin, a lot more of it would be leaking out. So we say that albumin helps the blood hold water. Another protein in plasma is fibrinogen. Fibrinogen helps with blood clot formation. It actually helps to coagulate the blood. The fibrinogen, when it's in this form, like fibrinogen, it's dissolved, it's liquid. But once the clot starts to form, the fibrinogen actually converts into a solid form, so it's more like a fiber. And so hence the name fibrinogen, because when it solidifies, it's more like a fiber. And like I said, that's a process that occurs during blood clot formation. Another category of proteins are referred to as globulins. I'll say plural because there are several different types of globulins. Globulins, some globulins defend against disease. We refer to them as antibodies. because they're part of our immune response, and so they're anti-invaders, right? They're against things that invade the body, so we call them antibodies. Other globulins transport fats. Transport fats through blood. As you've learned in some other class like chemistry, you know that oil and water don't mix, and since blood is mostly water, any fats that we might be absorbing into that blood, they would pool to the top of the bloodstream if we didn't have some way of sort of making them go with the flow of blood. And so some of our plasma proteins, some of our globulin proteins, it's their job to transport the fats through blood. And other globulin proteins will also help with clot formation, help with the blood clotting process. And so you see there's a wide variety of proteins with a wide variety of functions. And so don't let that number fool you. Even though the proteins comprise only 7% of the plasma, their functions are far-ranging and significant. All right, well then if you do the math, 92% plus 7%, that doesn't quite add up to 100%, so that leaves us with, about 1%, okay, 1% in a category that we'll call other. And in that category, what other things might there be in plasma? Oh, things like ions, calcium ions, sodium ions, all those little charged particles that you learn about in chemistry. Gases like oxygen and carbon dioxide, those would also be in plasma. Glucose is a sugar. It's our preferred fuel for body cells. So those kinds of things would constitute that remaining 1%.